For over 40 years, CR has been a world leader in designing and manufacturing innovative mining productivity technology for both surface and underground applications. With a footprint in every major global mining region, CR produces a leading range of products through two divisions, CR Mining and CR Digital. Our vision is to be recognized as the trusted supply partner within the global mining community, delivering highly innovative, productive, and socially responsible products and technology solutions. CR Mining engineers a suite of advanced products for both surface mining and underground primary production assets, such as cast lip systems and ground engaging tools, GET, for hydraulic excavators, rope shovels, LHD and wheel loaders, as well as dragline buckets and rigging, conveyor systems, and fixed plant wear products. CR Digital has a portfolio of technology for the optimization of surface mining, from blast hole drilling guidance and rock knowledge to load and haul circuit optimization for excavators, face shovels, and wheel loaders. The CR Digital product range naturally overlaps with the CR Mining range, with advanced sensing of GET attached to these production assets. All digital systems are underpinned by a suite of real-time analytics and open integrations that turn highly accurate sensing into real-time operational decision-making information. CR operates globally, covering most major mining regions, with dual headquarters in the USA and Australia, plus manufacturing facilities spread throughout Australia and China, as well as our Global Technology Center located in Queensland, Australia. CR Digital's Thunderbird 1110 drill optimization is a leading software for blast hole drill guidance and production monitoring. Available with StrataSense, real-time capture and display of the drilling index, the Thunderbird 1110 enables modified blast hole explosives loading for better fragmentation and reduced costs. How CR Digital's Thunderbird 1110 drill optimization system delivered significant surface mine drilling efficiency improvements in Chile. Using CR's Thunderbird 1110 system with StrataSense, Canadian miner Teck Resources was able to dramatically improve its geological knowledge of its Carmen de Andacollo mine, with major benefits for productivity. With the data gained from CR Digital's Thunderbird 1110, Teck Resources was able to develop a model to develop advanced knowledge of the site, which allowed for better planning and increased efficiency. The Carmen de Andacollo copper and gold mine is in central Chile, 350 kilometers north of the national capital Santiago and close to the famous Atacama Desert. Owned by Canadian mining company Teck Resources, the open-cut mine had a production output of 54,000 tons in 2019 and is expected to continue operation until at least 2035. The mine's operators are constantly looking for ways to safely boost productivity and efficiency. In 2014, a team of Teck geologists and metallurgists wondered if by analyzing the energy required to drill individual blast holes at the mine, they can improve their understanding of the overall deposit and potentially reduce production costs. To test their theory, the team, headed by senior geologist Victor Araya, enlisted the help of CR's team that built the Thunderbird 1110 system. The Thunderbird system relies on sophisticated software and an array of sensors to accurately monitor a range of drilling variables in real time. The Thunderbird 1110 system displays depth, rate of penetration, target depth settings, drill time, and estimated time to complete the hole, among other variables. The system also records all accounts for every minute across the day, while interfacing with the mine's fleet management system. The Teck team's working hypothesis was that the varied nature of the material at different locations at the mine would greatly influence drill-specific energy, the amount of power that production drills require to complete each blast hole. They wondered if the hardness of the material, the minerals that it contained, and its proximity to known features, such as faults, could influence energy requirements. To test this idea, the Thunderbird system was used to monitor and collect data on more than 10,000 blast holes drilled on-site over a 2-year period. Each blast hole was 11 meters deep and drilled to help create 10-meter benches. With help from Thunderbird, the team was able to collect and analyze data on the following variables: bit speed rotation, rate of penetration, torque pressure, pull-down pressure, and bit diameter. The data was used to determine the drill-specific energy required for each hole and to create a map of drill-specific energy variations. The data on drill-specific energy was then compared with the existing geological model of the mine and analyzed. The team found a correlation between the two data sets. For example, holes drilled in the vicinity of major faults required less energy to complete, reflecting the lower resistance of the material in such locations. Factors such as the composition of rock-forming minerals, the rock type, rock texture, and presence of veinlets of pre-existing quartz were all found to play a role in the energy required to complete a hole. Realizing the drill data that was harvested during the study expanded their knowledge of the mine's geology and its various domains, the tech team looked for ways to utilize it. Using an algorithm, they applied the data to the block model for the mine. The result was a model that was able to predict the behavior of the rock during blast hole drilling. The Carmen de Andacollo team quickly realized there were numerous advantages to their research. Using the enhanced block model, the mine is now able to optimize its blasting parameters according to resistance of the local deposit. Where drilling data has shown the rock to be soft, less explosives can be used, avoiding overblasting and the waste of resources. The model also allows operators to better plan for the use of expendables such as rock tools, which are likely to wear out more rapidly where the rock being drilled is harder. Another significant benefit is in the area of grinding. Advanced knowledge of the nature and size of the rock to be milled allows for better planning and, potentially, increased efficiency. The team's findings and methodology are published in the paper Drill-Specific Energy at Tec Carmen de Andacollo. Innovative thinking and a commitment to continuous improvement helped the Carmen de Andacollo mine enhance its approach to blast hole drilling with major benefits in productivity and profitability. CR's Thunderbird technology was crucial in harvesting the data necessary to determine and exploit the correlation between drill-specific energy and geological features. The Thunderbird 1110 systems allows miners across the planet to optimize drilling and blast hole resources, improve blasting efficiency, improve fragmentation, and better understand geology. From drill guidance to load haulage, CR Digital's Titan 3330 load haul optimization is a proven, industry-leading technology for hydraulic mining shovels, excavators, backhoes, and wheel loaders. Using highly sophisticated sensing and patented algorithms, the Titan 3330 calculates and displays the payload of each bucket accurately in real time and during motion before it is dumped into the truck. The Titan 3330 interface provides instantaneous improvement in production through exact truck loading to target, 100% to 110%, which we will discuss in the following two case studies. Our first case study showcases an Australian miner who commissioned a new production-class mining excavator. The challenge was placed to ensure that this new asset was promptly producing as much value as possible. The customer could not rely on the under-shovel weights provided by truck payload systems to guarantee optimized truck loading efficiency. Due to the design of truck payload systems, the feedback can be unreliable. For example, if a truck is on uneven ground, the axles become unbalanced and skew payload readings. CR Digital's experienced field technicians worked with the miner to install the Titan 3330 load haul optimization system on a Hitachi EX5600-6 backhoe. The production optimization system is specifically designed to maximize the productivity of surface dig units by providing accurate, real-time, pass-by-pass feedback to operators on truck payload, production rates, truck fill times, and a suite of other production metrics. Sensors fitted on the excavator identify and track trucks filled, aiding in overall site productivity. Operator training on the intuitive Titan 3330 system was rolled out once the system was installed and commissioned. Data reporting tools were provided to the customer to observe the impact of the system. As a result, the CR Digital Titan 3330 load haul optimization system delivered a 26% increase in instantaneous productivity, a 19-ton increase in median truck payload, 8% increase on base period. Additional benefits: 11% reduction of truck underloads, equating to an additional 209,000 tons of material. 22% increase in operational productivity, 26% increase in instantaneous productivity, 6% increase in truck fill factor compared to truck-rated capacity, and a 4% decrease in truck payload standard deviation. In our next case study, CR Digital was employed to help a miner based in the Pilbara operating a fleet of cat-face shovel excavators and ultra-class trucks in iron ore and waste materials. Due to extreme material conditions within the mine, limiting machine duty and attachment damage was high priority to the mine management team. A staged deployment of like excavators over multiple years allowed for the miner to learn from data collected by the first machines and apply it to the next by fully utilizing the Titan 3330 system. The challenge was placed to map the duty accumulated by each of the machines since their deployments to predict maintenance intervals and schedule downtime. CR Digital's experienced field technicians worked with the miner to install the Titan 3330 load haul optimization system on the fleet of CAT face shovels. The duty monitoring system is specifically designed to minimize machine duty by providing real-time pass-by-pass feedback to operators on the major attachments through hydraulic cylinder monitoring. Sensors fitted on the excavator identify bucket cycles and map hydraulic circuit loads at high frequencies. A duty summary of each individual bucket cycle is reported live on the Titan 3330 user interface. Operator training on the intuitive Titan 3330 system was rolled out once the product was installed and commissioned. The CR Digital Titan 3330 load haul optimization system delivered a 42% decrease in machine duty within the first 300 days, effectively doubling the maintenance interval for later excavators. Indicative analytics on mean time between failures based on recorded data, and high-resolution recording of hydraulic events and tuning performance results. Additional benefits included a 14.5% increase in instantaneous productivity and a 9.5% increase in operational productivity. Thank you for listening to a few of CR Digital's case studies today. As a world leader in designing and manufacturing innovative mining productivity technology and a footprint in every major global mining region, CR delivers highly innovative, productive, and socially responsible products and technology solutions. If you have any further questions, please do not hesitate to contact the team at www.crmining.com.
Scale testing is a testing protocol that we use where we scale down real-world scenarios into smaller machines so that we can test and validate the designs we come up with in a way that's cost-effective and time-efficient.
It allows us to actually test them in our live pit to provide the customer a control, but at the same time the end solution. The end solution is the absolute optimized approach for our customers.
It allows you to do a whole bunch of testing and adjusting quickly, cost effectively, so that you don't have to put mine site operations at risk. Traditionally, if you wanted to make a bucket design change, you're looking at hundreds of thousands, maybe even millions of dollars worth of downtime and manufacturing fabrication. With scale testing, we can manipulate the exact pieces that we are looking to improve. We can get the results quickly. We can be confident with that, and we know that that translates into the field.
It's particularly valuable when there's something innovative or new that we're trying to do, or perhaps where there's 3 or 4 different options that you might want to figure out which is the best solution to optimize something.
Products that are actually put through scale testing are the products that are really based around large capital purchases, large car slips, large buckets, stuff like that.
There's a lot of different ways we can do scale testing. First of all, you've got to understand what it is that you're digging in, and make sure you start by setting up your scale pit or your scale operation to match what's happening in the real world. So you're talking about bench heights, you're talking about particle sizes, densities, material selection, all that kind of stuff. Once you've got your pit scaled, you can then look at the actual machine constraints and scale that down to suit and make sure that you've got the right parameters scaled correctly.
With wear and bucket fill and void detection, we typically use sort of visual metrics, so cameras, we've got buckets with viewing ports. We also have a model of our Titan system on the machine.
So the Titan system allows us to record all the sensors that we have on the system in real time. So not only are we calculating the payloads and the fill energy in real time as we're doing this testing, allowing us to view it on the screen as we're doing the testing, we can also then take that data back up to the office and play that in real time in conjunction with the strain gauge data, which allows us to get a really informative view of what's going on with the machine as it's digging.
You can customize too far, where you end up saying, it suits something so specifically that you actually can't use it anywhere else. And that's the danger of not doing scale testing, because you find a specific site with a specific condition, you try and solve that problem and you create a whole bunch of others. So for us, putting stuff into the scale test situation, you get a result that solves a specific problem, but that can be used broadly across all their applications. Scale testing sets us apart because most of our competitors just don't have the ability to really test and validate something this way. they'll have to go to market either with something that's suboptimal or something that they just think is going to work. And even if it does work, you still don't know whether you could improve it. Whereas we get the opportunity to say, let's optimize it beforehand and make sure that it then really delivers the right results. It's one thing to measure whether a system wears, but if you can't measure the productivity, you never know what you're missing. So that really gives us the ability to deliver extra productivity type results to our customers that others just can't do.
When we go down these paths on optimized solutions and utilizing scale testings, customers normally drop their guard because what they tend to see is us open up with a lot of transparent information and data that's driven to the decision that we provide. So validating that before it actually gets seen in the field allows them to have a lot more faith in what is brought to the table by CR, because we believe in our solutions that we bring to the table. We believe in everything that we validate to the customer.
Many customers have got a tremendous amount of value out of the scale testing, but something that we often hear customers say is they're amazed at how accurate and similar the scale testing is to what they actually do on site. It's been highly effective, highly valuable, and yeah, we certainly want to do more of that going forwards.